Okay, it's 2 p.m. Great to see so many people have stayed on from Hugh's webinar there, and we'd like to welcome along to the final plenary of the EEBS, Mr. Jeff Colley, editor of Passive House Plus magazine. Welcome along, Jeff.
Thanks very much, Andrew. Thank you. Good afternoon, everyone. My name is Jeff Colley. I'm the editor and publisher of Passive House Plus. It's a magazine focused on evidence-based approaches to sustainable building. It's my pleasure to introduce the final session of the Energy Efficient Building Seminars. This series of events has been a collaboration between some of the most knowledgeable people I've come across in the low energy building sector. It's tapping into their collective wealth of knowledge and experience. It's Partel, in partnership with Core, Daikin, NorDan and Harmony Timber Solutions, are providing something that the industry really badly needs in light of recent changes to the building regulations. So during the 4 weeks of seminars, they provided an integrated approach to sustainable building design and construction, all in accordance with the nZEB requirements. They have every aspect covered. You could literally build an nZEB where every component which impacts on delivering the nZEB standard, the structure, insulation, windows, thermal breaks, and air tightness products, renewable heating system, and a mechanical ventilation system is provided by these 5 companies. At Passive House Plus, it's our firm conviction that the industry must adopt proven evidence-based approaches to sustainable building to ensure that the nZEBs we build don't just work on a spreadsheet, but in reality. The risks of underperformance are real and they're significant in terms of higher than expected energy costs, poor indoor air quality and overheating, and in buildings which don't endure. But with the right approaches, we can create buildings which stand the test of time and actually help to improve the comfort, health, and the bank balances of their occupants, while simultaneously contributing to the climate fight. So we're delighted to be involved as media partners for this webinar series. But anyway, for now, the plenary will start with a whimper. I'll be delivering a short presentation about nZEB market trends based on my latest analysis of data from SEAI. I'll just get cracking with that. Just 10 minutes of your time, 10 minutes you won't get back, I'm afraid. But sure, here it is. I'll crack on with it. So, you know, I've taken an increasing interest in data journalism over the last number of years, which is just, you know, it's very self-evident what it is, really, I suppose. And we have this extraordinary data source in the National BR Research Tool, which SEAI have published. It's basically a spreadsheet you can download from their website, which is updated at midnight every night. Of it's based on every building energy rating for a dwelling that's ever been published. There's nearly 1 million of them at this stage, and it's nearly all of the data that went into the generation of those BERs, with the exception of 3 very useful pieces of information that could be, I guess, could be damaging in the hands of a journalist. The energy performance coefficients, the carbon performance coefficients, and the renewable energy ratios, the 3, I guess, headline targets, or 3 of the headline targets in terms of determining whether homes are actually complying with the building regulations or not. But we won't gripe too much. First thing is to understand the data source. So I downloaded the data for this analysis on the 11th of March. It includes all published building energy ratings for new dwellings. The vast majority of self-builds are not included, and this is because of widespread non-compliance among self-builders with the legal requirement to publish a BER prior to occupancy. We think about 3/4 of self-builds, by our estimation, are not included in this analysis. But other than that, where a property is transacted, the conveyancing requirements are tight enough that BERs are being obtained, we're confident, at least when the transaction is completed. So if we look at this graph here, you'll see the standing totals for homes where the year of construction was listed as 2019 or 2020. It looks pretty devastating in terms of the drop from nearly 18,000 in 2019. That's a standing total. BERs are still being published for that year and for 2020. But it's not as bad when you take account of the lag. So this next graph shows basically the same figures, but taking account of not just the year of construction, but where the BERs were published in the same year as the year of construction. So the drop in that case is from 11,000 to 7,700 odd. Still a drop, but not as worrying and more understandable given COVID. This graph here shows shows the BERs in each year of construction divided by the month the BER was published. And if you look at, see there's 26 months in total listed on this. I couldn't put the actual names of the months on it because of the way this analysis works. We've got, so 26 months have happened since the start of 2019. That's why that graph is longer. And then you've got 14 months since the start of 2020. And you can see similar curves there. You can see here, this is month 16 and 15 through 17 are when the first lockdown happened for that's the 2019 homes, homes that were built in 2019. BERs were not being published for them in the first few months, or rather in March through May of last year because of the lockdown. And this, by comparison, was the same data for the previous year. So very similar kind of curves you'll see, but without the pronounced drop happening because of that lockdown. And if we look at the actual, the substantive stuff energy-wise, the first thing is the primary energy targets as it stands for 2019 TGDL homes. And this is from here on in, we look at 2011 TGDL homes versus 2019 TGDL. In other words, the nZEB regulation homes. Over the last, and this is specifically looking at homes where the BERs are published over the last 2019, 2020, and first couple months of this year. So we've gone from 50 kilowatt hours per square meter per annum, 50.06 on average for homes built to the 2011 Partel, to 40.8 for the nZEB. Now, that's under what the department had indicated was likely to be the nZEB target of, what the EPC minimum compliant or maximum compliant EPC of 0.30 would likely translate to in primary energy terms of 45. But we can't say absolutely. It depends on the mix of housing. The size in particular is a factor, and we've seen homes in the low 30s need, as the target for compliant with nZEB, and in some cases homes up to 60 kilowatt hours. It really depends on the size and shape of the house. By BER bands, you can see nearly everything is A2 now. I'll whistle through these to kind of not take too much of your time, but we're just under 93% A2, up from 47% A2 last year. Still comparatively little movement in terms of A1s, and you get the odd. There's I don't know, there's maybe one or two homes that are E2 rated this year, so that looks like a data input issue. That is one of the issues you get with the BER data. When we get into the actual elements, opaque elements, so the U values for walls, roofs, and floors, they're basically largely unchanged. Floors, there's some signs of an early improvement, but other than that, walls and roofs are basically identical to where they were for homes built to the previous version of the regs. I've excluded floors and roofs where there was a U value input of 0, which would indicate that there's a floor or ceiling between two apartments, for instance, in the same building. With window and doors, there is more sign of improvement, from 1.2 on average to 1.16 for windows, and then 1.3 down to 1.15 with doors. With regard to Y values, there's no discernible change, and the industry really isn't engaging in this regard. So we're in and around 2/3 of new homes are using a Y value of 0.08, and less than 10% are actually bothering to calculate the Y values, which may be a missed opportunity from a cost perspective, you'd have to say. Then you have obviously in the region of a quarter that are using the default of 0.15. Air tightness wise, there have been some improvements, 2.83 down to 2.55. It's good progress. Still a long way off best practice, and the kind of levels that you can achieve with Passive House, for instance. But to put it in context, we've gone from 11.8 was the average from admittedly a small enough sample size from the Energy Performance Survey of Irish Housing from 2005, down to more than 4 times lower than that total now. So the industry does need, I think, a bit of recognition for that improvement. Still some work to do, I would say, but it's pleasing to see that. Then I've divided them up by air tightness bands, and you'll see that the majority, 60% are below 3, 20% are in this 3 to 5 range. There was missing data from the BER database for 13.9%. That's an issue that SCAI are working on updating. The data is still included in the BERs. It's not transferring over to the national BER research tool. So that's an issue. And then there's a small issue of apparent non-compliance of 3.3% of the nZEBs. That, in part, I believe from talking to SCAI about this, appears to be down to people mistakenly using the 2019 TGDL instead when they should have been using 2011 TGDL. There's a little bit of issue with data input. Wall types, there's a health warning required for this because this is not one, I gather this is not one of the fields that is auditable for BER assessors, so there's not as much attention placed on it. But you can see what's evident from this data, and I've kind of aggregated a few of the different wall types into different groups here. The names in the actual research tool are curious, like 225 mil solid brick, for instance, or 325 mil solid brick, which they don't really correspond to anything we'd really see out there. I think that's meant to be single leaf block with external insulation. So we've what you'll see here though is that timber frame is growing substantially, over 30% from the early signs data on nZEB. And what isn't evident here, but is visible in a narrative field associated with this with this wall type, this first wall type category, is that categories which SCAI didn't include when they were sort of developing the system in deep, such as ICF and steel frame, they are there being added in the narrative field, and they're growing quite nicely. They'd be evident in the other fields and in the blank field, along with a lot of other walls. I mean, cavity wall types come in there as well. It's a bit of a mishmash, to be honest, and lots of assessors don't input information into the narrative field. When we look at air tightness by wall type, again, the same health warnings apply for the reasons just described, but a lot coalescing around about sort of the 2.5 total, with hollow block substantially worse, and solid mass concrete much better. But I mean, I would say with the solid mass concrete figures that again, the sample sizes for that category were particularly small, so I wouldn't necessarily read too much into it. Ventilation-wise, there's been a profound collapse in the natural ventilation market, which I've unashamedly happy to see, because we believe very strongly that natural ventilation without some form of mechanical, fail-safe backup is not fit for purpose for low energy buildings. But what is apparent is that MEV is becoming dominant, and we also see in here one thing that I just corrected with SCAI this morning. There was a bunch of missing data which corresponds with this field on the right, exhaust air heat pumps. The growth of exhaust air heat pumps is not from 2.5% to 13.9%. We can't say that. There was a change in DEEP when DEEP 4 was introduced, which affected how exhaust air heat pumps are inputted in, and consequently it was coming down as missing data in newer BERs published last year and this year. So that's indicative of that growth there. And then in terms of heating systems, one of the big headlines, I suppose, is this profound change that we've had. Heat pumps are, almost the only thing that's happening in new homes in Ireland. 93% of new homes. Oil, by comparison, for a country where half of the housing stock or more was on oil historically, 0.2%, doesn't even show up on the line here of homes built this year. Homes built to the new Partel have oil boilers, so it's extraordinary to see. It's gotten to the point where at least in the context of new builds, the government doesn't even need to ban it, because it's dead already. And that really concludes that presentation. Thank you very much for listening. Anybody who wants to find information about us, that's our website. All of our back issues, I should say, are archived digitally and freely available. And you'll find out on the site how to get the magazine. There's kind of free and paid ways of getting access to the actual printed magazine as well, both the Irish edition and the UK edition. So I'll go straight on from that into introducing our keynote speakers. Yeah, for anyone who missed their presentations, they're all recorded and posted on YouTube channels, on the Partel and Core YouTube channels. We're going to now, we've also got each of the 5 presenters is going to give a brief summary of their presentations. The first speaker in that regard is fresh from speaking not 20 minutes ago, is Hugh Whiriskey, Technical Director and Founder of Partel. Hugh will round off the topic related to air and wind tightness, thermal bridging solutions. He's a certified passive house designer and a specialist in sustainable building and energy efficiency, with extensive knowledge in design and construction management, building fabric, and heat recovery ventilation. With over 20 years of experience, Hugh has particular experience in low energy construction, engineering, and architecture. He believes that increased efficiency in buildings is accelerated by choosing smart building envelope systems, and this leads to intelligent energy consumption and building longevity. So I'll hand over to Hugh.
Thank you, Jeff. Hopefully everyone can see my screen okay. Yeah, Jeff, you're a fountain of knowledge, always interesting and generous with that, those insights. Thank you. So the idea today, just to take a short overview on the main points from the applications and maybe the why for air tightness, wind tightness, and thermal bridging. The main change that kind of relates to what Jeff was just speaking about is the changes to the maximum energy performance coefficient and the maximum carbon performance coefficient. So both reduced significantly. I guess we're looking at, with the EPC, 30% of the 2005 reference house, and with the CPC, 35% of the 2005 standard. So really kind of significant steps, as Jeff has kind of alluded to, over time. And I think, as somebody might have mentioned in the questions, it's more about compliance with those and less about compliance with an A2 or an A3 or an A1. It's really that we're dealing with. The air tightness, we need to be below 5, and if we're below 3, we need a mechanical ventilation system to comply with regulations. And look, lovely to see, as Jeff has pointed out, that natural ventilation is dying, thankfully, not just from a sales point of view. I agree with, I guess, Jeff and most of the stakeholders that mechanical ventilation is a safer approach generally for the occupants. There's a few things in Part F that the renewable energy contribution is based on energy demand, and the U values have also changed slightly. When you're installing air tightness, we try to get people to be aware of the differences of maybe what a system is and what a collection of parts. We like the Passive House Institute component database because it takes all products together, tests them as a system, and it's the only way that you can do that. And this is actual testing. I managed to visit the Passive House Institute, which seems like a dream now. Would be really nice to be able to do that again, but this is actually what the testing looks like. So you're seeing a timber, concrete, and also membrane to membrane tests. So a really nice way to validate what the quality of the overall system is like. This is a nice slide to help explain one of the misunderstood products on the market. So variable technology or smart systems, intelligent systems. This is the Variflow product, and it shows in summertime the membrane can open and become quite open to facilitate additional drying. In winter, the pores can close and help to protect the construction. those types of products are needed in some situations, not in all situations. So definitely reach out and consult, and don't be afraid to ask for WFI analysis in your build-up. How do we get airtight? It's a three-part process. It's design in the detail. So it's the architect, we have the Q&A on site, and the two-part testing system. So test when membranes are kind of exactly at the stage you see in the photo, and a final test on completion. We focused previously on wind tightness. It's an area that I feel equally strongly about for a couple of reasons. One, it helps to improve the final achieved or actual real U values. But secondly, the quality of the products matters a great deal. So there's a huge variance on that. And we're trying to educate people on how products are produced and how you can help to see the differences between those. We also looked at airtightness tapes, and in a similar way to the overall systems, the quality of the tape matters as to how the overall system works. And there's a lot of decisions and choices that you can make. We showed that the ideal kind of, I feel like, balanced adhesion that we look for, it's not all about the peel or the initial tack, it's more about the final and long-term strength of our tapes. And lastly, we looked at thermal bridging. This is a structural thermal bridging installation. And yeah, Jeff, really interesting to see that people are kind of ignoring thermal bridging. I'm hoping if we continue talking about that yeah, for more than one reason, there'll be some improvements. But as you mentioned, I actually think it impacts dramatically on BEOs, and there's real savings together with the better quality building that people can achieve by focusing on that. I think that's me for now, Jeff, so I will hand back to you.
Thanks very much, Hugh. Yeah, the thermal bridging issue it is a significant one, and it's a missed opportunity. And you rightly point out it's one of the issues that can impact on the robustness of the building from a condensation damp and mold perspective as well. So it's, you know, evidence-based approaches address those kinds of matters, and that's something that we need to see the industry engaging on more. I should say that we do feel that there's a lot of people out there building to much better details than they're inputting into deep. And therefore, you know, using either a 0.08 or a 0.15 when the reality may be far better. Anyway, for next. The next speaker is Andrew Butler. He's going to give a summary. Andrew's is technical business development manager at Core. He's going to round off the topics he covered relating to the use of EPS installations solutions, and there's a varying kind of range of options for using them. Andrew has an extensive background in engineering and architecture, specializing in low energy construction and specifically fabric first approaches. He has worked on projects across Ireland and the UK, designing sustainable residential and commercial properties, as well as working on large commercial and civic projects with Core's void formers. He has a passion for climate action and for the energy consumption of buildings, for kind of make reductions there, and aims to promote and educate sustainable living for all. So over to Andrew now.
Brilliant. Thank you very much, Jeff. So yeah, just a very quick recap on, I suppose, what my presentation covered a couple of weeks back. I suppose we were trying to give everybody a feel for EPS, how it can work into your construction project, how it can help save money, reach those lower U values, solve your thermal bridging, I suppose, in a cost-effective way. Being EPS, I suppose I was leaning on the fact that the EPS product, it's a known entity. It's one of the longest materials on the market in terms of insulation. So proven thermal and physical properties which don't change over time. So we started looking at the wall solutions, and we looked at bonded bead and how that works very well for new build and retrofit, certainly from the new build end of things, in terms of speed, buildability, cost savings, reducing our thermal looping, issues with maybe skilled labor shortages on site, how that's a very viable solution. We have, as part of all our products, we have typical details, and I would have shown these at the time, the thermal bridging. So this kind of, I suppose, ties into the Y value, like Jeff and Hugh would have mentioned there. We have these termly model details. There's only a certain amount of people in the country qualified with the NSAI to issue these details. So we have all these there that people can use and help to bring down their Y values very significantly. So whether it's a bonded bead product or even our external insulation product. So the way that the external insulation works, and again, we looked at the target of the new builds and the retrofits and what we needed in terms of external insulation. So we were looking at maybe the likes of our silver EPS boards. So you see it there, that picture in the top right corner. And the way that the external insulation market works is it's NSAI registered render systems will supply the overall warranties on the systems, and our boards would provide, I suppose, the component of the insulation as part of those systems. Very, very usable on retrofit and new build situations. Again, because it's an EPS product, we can save money potentially on a product on a project by using something from our range of core solutions in this regard. So that was our external insulation. Looking at floor insulation, so again, floor insulation, this can be used in new build or the retrofit end of things. I suppose our most popular product would be the silver board, which you see there in the picture, whether it be under a concrete slab or whether it be under a screed situation. So you see here we have our silver EPS 70 board. We have some underfloor heating and a screed above it and our slab below it. So we have, I suppose, various different types of boards available, depending what the project is, different densities, different thermal performances, depending on what your project is. We should be able to assist, whether it's domestic or commercial. And again, because it's an EPS product, when you use that product at the start of your project, in 50 years, 100 years down the time, physically, thermally, it's doing exactly the same thing. So there's a great bit of confidence using an EPS product. I suppose that the one thing that was a little bit different from build types and looking at our insulated foundation system was a very simple way of reducing our thermal bridging, how to get to our compliance with Partel. So we're going to use an insulated foundation system. We're going to see a U value in the floor around about 0.1 by default. So we're going to blitz any requirements of Partel and nZEB, all those new regs. And again, if we use our clever thermal modeling, our details at the perimeter, we can get cost savings in our builds very, very simply by using some sort of a system like this. It's not going to cost you any more on a project by using a foundation system. And plus, I suppose I just went through the ideas behind it and how we gained our NSAI agreement certification, which made us, I suppose, fairly unique in the industry, that we're Ireland's only certified insulated foundation system. So we have a lot of backup information for structural engineers, architects, you name it. And just, I suppose I touched on our sustainability. So EPS as a product is recyclable, which is a great news. When we look at a bonded bead, you only pay for the material that's used. We're not sending boards to landfill. EPS can be recycled. And to quote some nice, fantastic information in Passive House Plus magazine, there was a study looking at, I suppose, embodied carbon. So we're looking at an insulated foundation system versus traditional builds and how we can save on the amount of concrete and embodied carbon. And I suppose the last thing from our sustainability point of view is that we're the first board manufacturer in the country to have an EPD. So all that information is out there available for people. And just the last thing is just our technical backup and what we can do for people in the industry there. No matter what place you are in the industry, whether you're a designer, whether you're the builder, you reach out to us and feel free to get in touch. We're always happy to help you. And that was me.
Thanks very much, Andrew. It's very, very informative. And I'm delighted that you mentioned EPDs and the life cycle assessment end of things. That's the next big target for the industry. Sure. And in fact, it's something that we should all be considering about in a future seminar series. Thankfully, the partner companies involved in this event all, I think, in their various ways, from the digging we've been doing into this, have products and solutions that can assist in that regard. Whether it's core getting an EPD and showing substantial embodied carbon reductions with a passive slab foundation system compared to conventional foundations, whether it's Partel with the recycled plastic thermal brakes, whether it's Daikin with the new refrigerants that they developed to reduce the global warming potential their units, whether it's, I mean, I could go on, whether it's NorDan with the sort of 60-year design life on their timber alley-clad, I think it's for the timber alley-clad windows, and then also with, of course, with Harmony Timber, just, you know, timber frame tends to fare extraordinarily well, especially when you compare it with the likes of a cement board rather than a block or brick externally. But our next speaker is the indefatigable John McMenamy, the technical manager of NorDan Vindeur. John will approach the topic related to Windows solutions to achieve the nZEB standard. He's worked in the construction industry for 35 years, starting as a carpenter with a focus on timber frame construction and offsite modular buildings. He joined NorDan in 2004, including a spell with NorDan UK, looking after their certification and testing. He's been involved since then with the specification and installation of windows and doors for large housing developments and one-off houses. And I personally have benefited from time to time from his kind of honest broker, very technical approach to understanding the subject. And so I'm looking forward to hearing what he has to say.
Okay, good afternoon, everybody. I'm just going to try and share my screen here. Share. Right. Can you see the shared screen now? Actually, I can't hear anybody.
Yep.
Right. Okay, great. Thank you. Right. Good afternoon, everybody again. Just to recap them, I suppose we looked at the difference between different types of timber and composite window constructions previously. When it comes to nZEB, the only real difference will be in the U values. And we can see that the samples, the worked examples given in TGDL in the annex there, talk with approximate U values of 0.9 and a G value of 0.6. Backstop U values are 1.4, but I don't think we'll see much of that. Now, the only thing perhaps in terms of that U value and G value, we would have a slight concern that overheating might be a risk. And it's something to be cognizant of. If you've got very airtight buildings, you've got high G values. I mean, if you've got large amounts of south-facing glass, it will get pretty warm inside with those sort of G values. So we would expect those to come down, particularly on south-facing elevations. Now then, yes, the window, multifunctional, it has to do an awful lot. I gave a quick list of things it had to do in the previous presentation. I'll just run through it there again briefly. There was one important bit that I left out: provide sufficient daylighting, allow visual contact with the surroundings, keep heat in, keep heat out in the summer, ensure good weather protection, allow controllable ventilation, keep out excessive noise, ensure safety, stop people falling out. Now, on top of all that, the window and the door is pretty much the only thing in the building fabric that is designed to move. If anything else is moving, you've got problems. So not only we have to make sure the thing is very efficient in terms of air tightness and energy performance, it also has to be physically very robust. So perhaps the big issue we would have here in terms of windows suitable for this country and, say, Central European climates is the frequency and intensity of wind-driven rain. This map here showing two data sets between precipitation and average wind speeds. You'll see that most of the island is either severe or very severe wind-driven rain. So buildings, windows in particular, have to be designed and installed to accommodate that. Now, this particular book I mentioned in the presentation, printed and provided by Trada, Wood Windows Designing for High Performance. Not necessarily just for timber windows. It's very good general reading about windows and window specifications for anybody involved in specification and construction design. Now, some of the parts of it that I didn't touch on in the first presentation, but just briefly here, it's important that designers of windows determine the required level of weather resistance. It is not sufficient merely to quote compliance with BS 6375. And that goes for a lot of things. We would see that in specifications. Just a standard is quoted without any classification to that standard. Another thing to look at, that the use of insulators within the window. We and other window manufacturers can get a standard window down to about 0.8. If you want to go any lower, you're starting to put thermal breaks in the window. So it depends what sort of U values you want to get to. We can provide anything from the 0.9 in the worked examples down to 0.7. Now, another one that crops up in questions to some of my colleagues at work is the number of seals in a window. This design guide by Trada touches on the subject here, and you'll note that the text there says that the care must be taken to avoid any moisture becoming trapped between the two seals. What does that refer to? Look at these sections here. We've got two particular window samples. You've got an external seal there and an internal seal there, and the lower one, there's an external seal on the outside and an internal seal there. That's two seals. You'll get examples now with 3 different seals. This particular window here has only 1 seal. Why is that? The 1 seal at the back there will provide adequate weather protection. With the multiple seals, there's a risk of moisture getting past the external seal and getting stuck in that cavity in there. With continued wind-driven rain from the outside, still driving water in, there's very little way for it to getting out, and it can sometimes get past the inner seal and leak into the building. Now, this then goes back and looks at the principles of good window design as recommended by Trada. Locate the seal at the back of the window, no horizontal surfaces, so there's no place for the water to puddle, and a pressure relief zone to de-energize the wind so that there's no energy in it to carry the water back to the seal. Installation detailing is critical. These are typical installation details showing a check reveal and a standard flush reveal. The check reveal provides much better protection from wind-driven rain and will help in the longevity of the seal insofar as it's protected particularly from UV light and breakdown. The installation details, again touched on by Hugh earlier on, and Jeff, we have accredited details from Scotland which show the psi value on there. It's all well and good having a particularly well-performing window. It really has to be installed properly, and all the detailing, not just in terms of weather, but the structure has to be adequate for us to fix the window too. Lastly then, again, what sort of certification and what sort of performance you should be looking for. Just a summary: third-party certification, perhaps performance certification in terms of air permeability, water tightness, security specification, sustainability, it's PFC, FSC, environmental product declarations. We have those for a range of our windows and doors. And then again, warranties, what sort of warranty you should be looking for. And that's me done and finished. Thank you.
Thanks very much, John. So next up, we have a summary from Ian Killoch, heating sales engineer at Daikin, who will round off the topic related to the omnipresent air-to-water heat pumps now that are in almost every house in the country. Ian's worked every new house. Ian has worked in the renewable energy industry for almost 2 decades now, including, as I recall, a spell in solar PV, with a huge passion for climate action and for the transition to energy building in general. He's worked on projects internationally, including in Nigeria, Germany, and Sweden. He's dedicated to helping Ireland reach its climate action goals by 2030 and beyond with sustainable construction and living. So over to Ian.
Hi, Jeff, and everybody. I hope you can all hear me pretty well. I'm just going to touch on briefly some of the things I spoke about, and what I was looking at really was the differences between monoblocks and splits. As we know, heat pumps provide what we call a low temperature heating system, whereas everybody's used to the standard radiators. You touch a radiator, it's very hot. And when you look at what we call low temperature systems, if it's radiators, they tend to be just lukewarm because the flow rate is running about 45 degrees instead of the traditional 60 to 70. Or if you have underfloor heating, you're looking at 35 degrees or maybe less, depending on the slab that you have. The real differences between monoblocks and splits, as I touched on, a split tends to be, the easiest way of remembering is an outdoor and an indoor, split in two. Or a monoblock, whereas is a outdoor unit, more components in it, and the tank inside. And it's a 3-port valve that decides either to call for hot water or for your space heating system. The couple of advantages and disadvantages really that I touched on were splits. You'll see the picture there in the top right or bottom left, or what we call our split system. That's the indoor unit. It's very neat. It's only 600 square, so it's the same size as a washing machine, if you like, and all your components are within that. But the connection to the outdoor unit is refrigerant that's in the line. And when you have a refrigerant, it's certified to minus 30 degrees. We know their experience throughout Europe, particularly we supply a lot of heat pumps into the Scandinavia, the Nordic countries, Northern Russia, etc., where they will work at way above minus 30. You're looking at minus 40 degrees. The big advantage is sometimes some of the housing associations and the county councils look at the fact that you will never, or a private house even in that case, you will never have a freezing issue if the power goes out. So that can be a big advantage. Footprint, as I say, is the one I touched on briefly. And with a monoblock, you've got to remember the pipe work is going to be 1 inch. So generally 1 inch copper. The internal bore must be 1 inch. And this can be a little bit more expensive to do the installation, because by the time you join up all your pipe work, get out your bends and that, put in your 3-port valve and plumb it can, the labor element can become a little bit more expensive. Split systems also, under the heat pump tool that SEAI provide, the designer sign off, will always be more efficient also. Monoblocks, though, are starting to come in, as Jeff touched briefly on, with new refrigerants, R32. Daikin were the first in the world to introduce that. In fact, we're very proud of the fact that the first in Europe to use it were Wexford County Council in a project there 2017, 2018, 12 houses down in Wexford, and the 5 of them used the new Altherma 3 with the R32 refrigerant. And you will see that all manufacturers will move towards R32 into the future, because it's much, much cleaner for global warming potential. It's only 1/3 of what is existingly used. 410As and that, you're only looking at around about 20-26% if there was ever a leak. It's also much more efficient. There's less charge used in it as well. So you will see all heat pump manufacturers moving that way. Briefly then, just a touch to wrap it up then, really, the emitters is very important. Whether you can use underfloor or radiators. Radiators, we know those popular in Ireland, water filled. You have the choice of aluminium or steel. And steel is a little bit cheaper to buy, but because it's steel, the output isn't quite as efficient, so you will have to increase the size. If you were putting in say an oil or gas boiler, for instance, and the radiators that were there for that, if you're using the same for a heat pump, it will be roughly 20 to 30% bigger. So it does take up a little bit more room of the wall, and that's to give you the same output as because you're going at a 45-degree flow rate. Aluminium is very, very good, very efficient, takes up less space in the wall, but the fact is they're a little bit more expensive. For a homeowner doing a self-build range, it's not going to be really an issue, but if you're a developer, maybe doing 160 houses on a site or something, it could be a little bit more costly. So really with a heat pump, the important elements are, first of all, fabric first, I would always say. We're building now to A2 standards, so we know it's heat pump is kind of a bit of a no-brainer, and Jeff pointed out in some of the slides there. But for retrofits, you've got to look at certain elements, make sure that you have a lot of insulation in, the ventilation is done right, windows and doors, and then look at your elements. And retrofits really are going to be a radiator job. It's going to be probably upstairs, downstairs, and then about a controls on that, a good thermostat. That's particularly needed, because we all know a lot of houses going in the past, there are boilers and there's no what we call interlock, no thermostat. It just, the boiler runs away all the time. So I'm looking very interested in taking any questions that we have from the panel when it comes through later on, from anybody who wants to join in. And that's really covering very briefly what I covered there the other day in my air to water heat pumps and introduction. So back to you, Jeff.
Thanks very much, Ian. So the final summary is going to be delivered by Martin Williams, the Contracts Director at Harmony Timber Solutions, who's going to talk about, obviously, timber frame structures and their kind of solutions in this area. Martin has worked on projects in Ireland and the UK and has led developments in the industry that have impacted on quality control and the quality of final delivered homes. His career is focused on timber frame technologies. Technology and systems. Particularly, I'm interested in the app that they've developed in this kind of quality assurance approach, which is most impressive. So over to you, Martin.
Thanks very much, Jeff. Can everybody see my screen?
Yeah.
Still see the screen?
Yeah.
Just thanks very much for all involved in the presentations in the last few weeks. I've got a lot of even the other presentations, so it's very informative. Just as myself. Just a quick brief about our company.
Martin, sorry, that's the presenter view that you have on there if you want to switch screens.
Clear now, Hugh?
Yeah, perfect.
We were established in the UK in 2011. We started manufacturing back in Ireland in 2015. We've 100 employed directly, indirectly, and we've actually commencement notice has gone in, hopefully with COVID, for our new factory. Just what we have on offer with this presentation, our timber frame structures, which will be external walls, internal walls, party walls, our roof trusses, and our posi joists. So just quick review, I'm just going to run through our walls, floors and roof trusses and how our offering will affect nZEB and any compliance to it. First, we receive it, we have an order. We're highly process driven. So each individual order we get, our client's drawings, we have an experienced team of designers. We will go through it. So we would take fabric first approach to do with cold bridging, thermal efficiency, air tightness. Our factory environment then, again, it's all processes. So it's computer to saw and everything is pre-cut for manufacture. Also, our factory is NSCI audited, which is audited every year. So all our processes of how we design, manufacture, income and material is all strictly audited. Loading and dispatch, we would work to critical delivery periods on site. So a strict delivery schedule for on site, on time approach for everything to be delivered for fitting on site. And on site, we've put a team of over 40 involved in different erecting crews. So for fitting our kits, our roof structures, our floor, metal web floor joists on site. We have 3 different walls on offer. Our 0.18 would just to meet the backstop value. Our 0.14, which is our most common wall, which will exceed the minimum regs, and our 0.12, which should be generally targeted towards our passive style and one-off houses. I'm going to go through our 0.14 and just give you a more detailed approach to it. Our 0.14 wall is, we go to our structure. Because of this, we can, with our thermal elements, we actually pick and mix probably the best of what's available to us to achieve a cost-effective solution for our client, which would be our end user, our builders, our one-off customers. We also would design into that full thermal bridging along the face of the studs and our air tightness. And with this, we also will, for ease of manufacture, ease of fitting, all that, we'll also look at structural elements as part of our design. Just a brief here on we will also try and achieve a full thermal break with our 50mm PIR along the face of our wall. This wall will achieve our 0.14, and we fit a mineral wool in between the studs. Some people will say why we use mineral wool, why we use PER. We use a range of different materials to get a most cost-effective solution for our client, and also then ease of fitting it. We also use an external membrane and an internal membrane We use a foil face membranes, which adds to our U value because of the use of emissivity within the air layer. Our air tightness complete envelope wrap. This will be our floor joists. We prefabricate all our floor cassettes in the factory, so we're able to design for the full span, for structural elements to them. We will wrap our air tightness membrane around our floor joist so we can achieve a full complete envelope, which adds to the end product for achieving good air tightness results. We also fit our OSB with glue and screw our OSB to the joists in the factory. So again, it'll reduce health and safety issues from working at height. Our cold roofs, we supply roof trusses and fit them with our timber frame kits. With this roof, we don't fit the insulation because it's the last product that probably go in on the site. We do fit the air tightness membrane. We use large rolls so we can achieve less joints on site. We'll also tape and join into our wall membrane. So again, we're achieving a full complete wrap. We also fit our service battens to the underside of the roof trusses, so your electrician, any of the services can be ran in between them with ease. And again, this is if this is a 3-story situation, we have 30-minute fire tests completed to ensure that we comply to EN 1365. Our warm roof, we will fit the insulation on site along the slope due to many of the fact it's not accessible after. We'll also fit our air tightness membrane, and again, our service batten is fitted on the inside of that to allow electrician, plumber, anybody to fit their services to it. Our quality control, Jeff was asking something about our on-site app. We have developed our own on-site app. So all our site details, our detail handbook, all the health and safety elements relating to our site fitters, their safe pass, manual handling, working at heights, slinger, banksman. We also have a full checklist that we get all our fitters to check, and we use pictures which are taken and time and date. So each picture will relate to each house unit and plot number on a site. We also provide on-site access to this app with any of your health and safety personnel on site or the site foreman, so they can check our progress and that we're completing all the works as required. So this is all relevant then for BCAR, for checking and really recording all the information, because some of the information we will record on site isn't easily accessible for checking again and when it's covered up. Our other products that we supply to the market, we supply roof trusses for traditional build, block, brick, ICF and metal frame as well. We also supply feature trusses with some of our kits and with some of our customers as well. And when we're designing these, we'll also incorporate our air tightness, insulation, U value requirements as well. So again, the person can get the full benefit of the feature truss. Engineered joists, our metal web joists, we supply to traditional build again, block and brick, ICF, and the ease of fitting all the services in these more and more with mechanical heat ventilation, soil pipes, sewer pipes. They're becoming really a joist of choice at the minute on nearly all sites. And then just our commitment going forward, we have commenced. Commencement note has gone in for our new factory units, which are located here in Arklow, and we have a forestry setting, so it's in par with what we're passionate about. So that's me. So thank you very much, Jeff.
Thanks very much, Martin. So now, rather than recapping Hugh's presentation, given that it's so fresh in the mind, I think it makes sense just to launch straight into the final Q&A. And I think because the Q&A was missing from Hugh's session, it probably makes sense to start with those questions specifically. So I'll launch straight into them for you, Hugh.
Great. Yeah.
What is the difference between air changes as opposed to air permeability values?
Yeah, I guess that's the question about how it's recorded between like a passive house or Irish building regs. So with a passive house, the air changes. It's more about the air volume irrespective of surface area, whereas air permeability is it's both the surface area and the air volume. That's the real difference. They're not interchangeable figures. You have to measure each one separately. So for Irish regs, you're looking at air permeability. Certified passive house, it's air changes.
And yeah, exactly. And for this, just to be clear to everyone, when we talk about air changes in this context, we're talking air changes per hour under pressure test conditions, the same 50 Pascal pressure differential you'd have with the air permeability test. So this is through unintended air changes through infiltration, rather than the air changes that you actually want to deliver through your ventilation system. So the second one, it causes a lot of confusion when it says, don't shoot the messenger, please. It causes a lot of confusion when presentations like this seem to state that A2 is a requirement of regs, Partel 2019. It is not, and A3 can also be compliant. That's true. CPC and EPC prove compliance, not the letter, and that's just I guess an observation rather than a question. Let me see. I'll launch into the next one. Hi Hugh, with the decentralized system, what is the resultant impact on the BER results with the increased number of fans versus centralized? I assume the demand on the grid is increased, which will impact the renewable energy ratio.
Wind, I guess it's actually the opposite. So more smaller fans actually consume less energy. So it actually has a positive impact, and you'll actually see that the sharper manufacturers are moving more towards improving the specific fan power and with a little less focus on efficiency. So the latest units from Lunas don't have the same 9 or 89% or 90% heat recovery efficiency. That's reducing, but the fan power is improving. So you sacrifice one for the other, and in a low energy fabric first building, that can make more of a positive impact on the overall energy consumption.
Interesting. The next question, how many intake and extract units are required in a typical house? And do you require intake in all habitable rooms?
Yeah, if it's CMEV or heat recovery, you have an air inlet in all habitable rooms and you have an extract in all wet rooms.
Okay, great. Next one, the two more ventilation questions. There's approximately €3,000 saving for the Lunas MVHR unit over standard extract. What's the maintenance cost of the units each year that wasn't included within the comparison?
Yeah, I guess it's not included because there isn't a maintenance cost. That's actually the big difference. So yeah, if we change our filters or clean our filters, that's it. So when you're using a 30-year age-tested motor, that's why it's to avoid those the maintenance costs.
Okay, great. And what's the smallest unit available? Voltage needed 12 volts and power ranges?
Yeah, it's all 12 volts, a 12 volt system, but the actual outputs that it's using is based on its own controller. So relative to the settings that you've chosen, that's what actually controls it. So it's a maximum of 12 volts.
Okay, great. Now, next questions. I'll just go through them sequentially. There was a question I had, why do you feel that a lot of the data is missing from the BER? Is it to do with auditing pressures on the BER assessor and SEAI not designing correct input fields in the software? Most of the issues that we were reporting were to do with transferring of the data from the BERs into the research tool. There's no problem with the BERs themselves. There were some issues, however, there clearly are issues with BER assessors incorrectly adding information into DEEP. There were a number of BER assessors who'd chosen the wrong version of TGDL, for instance, and there were assessors as well who'd incorrectly inputted a value, an air tightness test result of 0.0, which I'd like to see. As a consequence of me raising the question, the guy I deal with in SEAI told me that there's 25 BERs that are being investigated for potential audit. So I'm sorry for whomever the unfortunate BER assessors are in that case. next question, Stephen McGovern. My experience would suggest, this is just a comment I think, that typical one-off builds will work with the ACDs regarding thermal bridging and air tightness. I guess it's larger developers that will aim for backstops and ignore ACDs if they get a simple pass. I don't know if anyone's got a comment to respond to that.
I think on that one, a lot of the larger developers are using offsite manufactured systems, which probably have better ACDs than the 0.08 if they're using a timber frame or metal frame, maybe some of them. So that's actually, and I know, to be honest, most of the timber frame companies, and Martin included, are looking at providing ACDs for their systems.
That actually squares with my own experience. Looking at the BER data, one of the things we noticed with the previous analysis was that there was more of a shift towards, for instance, mechanical ventilation. If we looked at the developer houses, because you can identify them with a fair degree of accuracy, we believe, from the BER data, and the Greater Dublin area, and generally in the urban areas, but in particular Greater Dublin area, there was a much higher tendency towards mechanical ventilation than in the rest of the country, even among developers. And the sense was that the guys who are working, the developers who are working on schemes around Dublin, are developers who've been at it longer and who are, you know, a bit more invested in the game, perhaps, you know, rather than the kind of smaller scale house builders, without not wanting to cast aspersions on that. There was a sense that they're more inclined to be keeping up with the R&D and more aware of the issue. Certainly, if you take Mick Cosgrave, for instance, you know, in Dublin, he's seen the consequences of not putting mechanical ventilation into apartments, for instance, and the issues you could run into there. There's a question from Stephen here with regard to thermal bridging. A lot more, just let's go through this. A lot more education is required in the industry on it. I have had jobs where architects don't know anything about what thermal bridging is, or what the requirements are, or are saying that the junctions are ACD compliant, but U values of the elements aren't suitable. If the SEAI data is looked at, just over 64,000 dwellings have a thermal bridging factor of 0.08. But if those details are looked into further, there are only about, so that's 64% or so rather than 64,000, only about 40% that's allowed to use 0.08, while 60% shouldn't be used as the U values are outside the allowable bounds. That's an interesting perspective. And I think there needs to be a massive education program for builders, designers, etc. on thermal bridging and what is the minimum / max allowed from a junction to be ACD compliant. I don't know if anyone's got anything to add there.
I guess it's more of a statement, Jeff.
Yeah. Okay. Stephen McGovern again, raising this issue of John. You didn't mention EN ISO 12567-2 for thermal transmittance, or EN 410 for solar transmittance.
I think 12567 is Hotbox testing of windows, which really isn't used. I think there's nobody has one in this country. I think anything in the UK would be probably in a museum at this stage. All the U values for windows are done to ES 10071 and 10072. It's a software exercise. That's the industry standard. Then when it comes to EN 410, that would be on the declaration of performance. It's a standard, that's the standard for determining G values. So they are on the declaration of performances. It's a given. It's not really something. I covered the U values, what's required in Part L, but to talk about them as standards in the presentation, I think they're pretty much there to do with. It's a basic. I don't think it needs to be mentioned, but the hotbox testing, that's simply not done anymore. It's a software exercise.
Okay. Perfect, thank you. There are a number of other questions. If people are okay for us to run over a little bit, this is a real doozy of a question. How can vent ducts be cleaned within a property? Long feather dusters?
There is systems available not in the UK or Ireland commonplace that can clean long ducted systems. So maybe it's a business opportunity for someone to get into, but I think generally they should be designed to allow for some cleaning, so access.
You can especially trained ferrets. They can be the chimney sweeps for ventilation ductwork, you know, for the modern age. I should say as well that there was a a paper, an academic paper published on the first passive house dwelling 25 years after it was completed. Now, the caveat here is that this is Professor Feist, the founder of the Passive House Institute. His own house is one of the 4 units there, and they got into the ducts and inspected them 25 years after. They'd never been cleaned, and they were essentially clean as a whistle. Professor Feist, as you might expect, was extraordinarily diligent. I think he had quite a fine filter and was replacing them like clockwork. So I'm not saying that ductwork cleaning is not an issue, but I think you can reduce the issue. You can reduce the risk through maintenance, proper maintenance of the system. So we've got other messages here. I'll just there's a couple of other to throw in here. Are there systems for insulating hollow block houses in the Dublin area internally, rather than using external insulation systems? I don't know if anyone else wants to take that, but my own view on that would be read Joseph Little's Breaking the Mold series of articles from Construct Ireland from 10 years ago or more, from what our magazine used to be, and we would strongly recommend people to avoid internally insulating single leaf hollow block walls for a number of reasons, principally because you've got risk of interstitial condensation behind the insulation layer. So if anyone wants to elaborate on that.
I'd agree with you, Jeff. I've sent people, I don't know how many hundreds of times to those articles as well. So yeah, well written, absolutely relevant. And
they were terrifying to edit, I can tell you, yeah. What are the main considerations in deciding between a centralized or decentralized system?
It'll always depend on the property. So for large multi-unit estates, it can be less complicated to use decentralized, also a little better on price. That can be a reason. But generally, it's a question about what's the most efficient system for a particular project. So I think it's best to evaluate your options, engage with engage with the specifiers, could be ourselves or whoever, and we'll guide you through the different options. So they're very much customizable solutions. So it's not just one. There's change relative to each property.
Okay, great. Question for Ian: are all plumbers qualified to fit a heat pump, and can we have cooling also? Can we have cooling also from a heat pump?
No, not all plumbers are qualified. Is a hard word to use. It's like if you had a Ferrari outside, want any mechanic having a go at it. You need experience in it, and most heat manufacturers are lending that technical training. I know in Daikin we are. With COVID at the moment, we're doing it online. We're doing a lot of our FQS guys, field quality engineers, service engineers are doing a lot of webinars. We're trying to get because we have a very good reputation in the market. We want everyone up to a very high standard, not only to be able to fit them and commission them, but be able to maybe do the maintenance down the road as well. It is new for a lot of people, and but there is a lot. Over the last probably 10 years, we've trained a lot of good installers how to do it. When they are trained with us as well, they are certified as a Daikin installer and that as well. But we will have a lot more training coming up, and we do it in certain centres around the country. And whenever this COVID situation, we get over that. To answer your second question on cooling, yes, Daikin units are reversible as well, so you can have the option of cooling, but you have to specify that beforehand. You need a reversible model, but we're starting to get a lot of inquiries on, as you alluded to earlier, there's a lot of, when extensions are done onto houses, maybe the kitchen area at the back, it's a lot of glass and it's getting very, very warm. So you can have what we call a convector unit. So you can do a one-on-one, you'll have one outdoor unit to use that as cooling, or the actual heat pump itself. When you're putting in initially, you can put in a heat pump convector to that, and that will provide cooling in that particular room or that particular area in the summertime when it starts to overheat. The caveat to that as well is if for some reason you needed a bit of extra heating, because it's heating as well in the winter, you would have heating from that unit as well. So I think it's something we will see a lot more of coming into the future. As we know, the houses here, we don't get anything like the heat we get in the Mediterranean or some of our European colleagues. But it's 3 or 4 weeks a year, maybe we will, and maybe we will start to get longer summers, which is predicted certainly. And we certainly see it as it's going to be part of the future for heat pump installations.
It's certainly something we're concerned about. Anybody who has an interest in this, we published a piece in the magazine a while ago on a study on an apartment building, a real building in Camden, that was monitored by academics from London South Bank University. This building, during the monitoring period, now London's a warmer climate than we have here, but on a day when the outdoor air temperature outside the building peaked at 28.9 degrees, this unoccupied, unheated building peaked internally, the operative room temperature at 47.5 degrees. Southwest facing, substantial glazing, and it wasn't even that low energy. It was a retrofit to a reasonable standard. So there are serious risks here and having cooling is a nice defensive strategy and stuff, as part of your heat pump, but designers need to wise up and take this seriously, or it will come back to haunt them. That's a real concern.
Yeah, it is an element we've developed into that. So we have units available for that. And as I say, all our heat pumps are that option of a reversible model. But it is something, you're right, Jeff, we're going to see a lot more of that coming in now, particularly with... It's
the same with space heating, fabric first, and then use efficient ways and clean ways of delivering the solution that you require in terms of whether it's heating or cooling. Hopefully, for the most part, we can avoid the requirement, but certainly I feel more comfortable having it in my armory. There's a question for Andrew on EPS. What's the long-term performance of EPS? What are there's a couple of questions actually there related for Andrew. What are the long-term performance of EPS? What are the time and cost savings when using the foundation system, if any? And what type of builds can be used with the foundation system?
Andrew has actually had to step away, Jeff.
Stepped away.
So
sorry,
I have qualified to answer Andrew's question.
I'll quickly throw in something. I've seen a rival system, so I won't mention it, but I've seen a building wrapped in external insulation done from 1966 with EPS in Ireland, and core samples taken of the insulation at the time. Sorry, about 10 years ago this was, the wall behind it was bone dry, and there was, I think, a hotbox test done to measure the U value, and of course, given that the only gas in the installation was air, the thermal conductivity was exactly the same, as the day it was installed originally, apparently. Time and cost savings for using the foundation system. I'd point towards Daikin Residential's. There was an article we did on the use of the core foundation system at Silken Park, the Passive House scheme in City West, which if you Google Silken Park and Passive House Plus, you'll find. And Jay Stewart, the head of R&D there at Daikin Residential, gave a very clear explanation for why it made so much more sense from a health and safety perspective in terms of having to move less soil around, I think, on site, and those homes were built. They were turning around houses in, I think, 12 to 14 weeks or so, using, interestingly, 9-inch hollow block construction, but with external insulation, and that's the big difference. No problem with the hollow block when you wrap externally. Though I would say, and maybe I have a question here to throw at Martin actually, if he's amenable, because I don't see much consideration yet in the industry for the embodied carbon issue when it comes to buildings. But is it something that people are starting to ask you? And are you seeing as well, to kind of really consolidate that and to capitalize on it, people integrating timber frame with products other than block or brick externally? Like a cement board, for instance, to reduce the overall embodied carbon.
There's not too much kind of requirement at the minute for embodied carbon. and I think it's probably just the way the market has been driven. More, I think that it will eventually come down the road to us, that more and more people will look at embodied carbon within the structure they're building. But at the minute, people are looking for a cost-effective solution to get to the building regs. So at the minute, you know, more and more one-off probably and passive style people are looking towards that information, but our larger kind of high volume market aren't looking at that avenue at the minute, and probably until the regulations allow for that and really push for it, and that but again, it'll be, you know, there'll probably be a lot of reluctance within the industry if that's, you know, pushed towards carbon tax, and because a large timber frame is probably still about 30% of the build market, and if a carbon tax does come in based on embodied carbon, there will be probably a real reluctance to let that into the market.
I think even the requirement to calculate it's going to be difficult. We'd expect to see something happening in green public procurement. This is something I'll be hopefully involved in to kind of make happen from a policy perspective. And in addition to that, the thing I'd say that I took some positivity out of, I've had conversations with two very substantial developers recently about ESG, environment, social, and governance requirements, basically, where they're going out to have to get money to finance their projects. Some of the biggest developers going. The finance world has started looking for, and what seemed to be actually, and I'm really surprised by this, very robust indicators of overall environmental performance, including, you know, actual energy performance, actual indoor air quality, and so on, and building life cycle assessment, including embodied carbon. So hopefully it happens. But I can tell you that I had one conversation with a quite a nervous sounding developer in this regard recently about having to kind of to move out of their comfort zone and start tackling this.
I have had conversations with some of the probably local councils who are looking at future developments of their own housing stock, and they are looking at embodied carbon. But because the change in the regs has happened in the last while to do with fire and systems tests, some of the probably where you achieve a lot of, you know, benefits with embodied carbon, they're not fully fire tested. So there's still a bit with a small way to go away, but it's just a matter of testing some of their systems. Because some of the systems in Europe at the minute are more embodied carbon, and with some of the local councils, they are discussing that and, you know, the benefits of them in their own bills. But still, commercially, it still has a little way to go.
Yeah, we have to move on it. The world is on fire, after all, they say, so we kind of need to move quickly on these things. Anyway, there are three final questions, and then I think we'll call it quits after that, if that's okay. One was, what's the expected lifespan of a timber frame home?
There's a design requirement in EC5 for 50 years, but the expected lifespan, there's probably no end for it. It's to do with the design and, you know, maintenance of it, that there's no moisture going to affect any of our structure. Like it's structurally over time, it's not going to deteriorate.
I think the likely outcome is that a retrofit or a changed use or a scenario like that should be what happens, a timber frame rather than a replacement through failure.
And certainly there are structures, timber structures. I think John McMenamy writing in our magazine not so long ago showed an example of a timber church in Norway, which was, oh God, I can't remember how old, but was it 1,000 years or something, John? Is that right?
About 800 or 900 years old. The stave churches there, they're made of timber. But I personally worked on a house in Switzerland that dated from the 17th century. It was a timber frame farmhouse, but it was every second generation or so they renovated. And that wasn't uncommon for that part of central Switzerland. So yeah, the lifespan of a timber frame structure is indefinite. It all comes down to the detailing and the quality of the workmanship of the initial build.
It's so essential to everything that we do here, you know, having that robustness, and we have enough of an understanding now of building physics. We know how to make buildings work and how not to, you know. finally, what do you think the current regs are a good stepping stone towards net zero energy buildings? Can you envision the U values improving much, or improved thermal bridging factors or efficiency of equipment? Or do you think we're almost at the max that can be improved? I don't know if anyone wants to take that.
I think logically, yes, they are close. They're definitely a good stepping stone, and it's pretty much what's been discussed here, that we'll see slight improvements in U values. We'd certainly like to see more onerous targets on air tightness, and that has a couple of reasons, but actually the longevity of buildings, if the air tightness is lower, we should expect the buildings to last longer. So I'd like to see air tightness, but after that, it's the carbon footprint. So it's the life cycle assessments. And I think that's what we need to be able to apply pressure to try have that integrated into the next changes in regs.
Absolutely. I think I completely couldn't agree more on the air tightness point. I'm reminded of Professor Feist saying that the reason they set the air tightness target for passive houses at 0.6 was not for energy, it was for structure, because of their experience that in summer wet, winter cold climates, if you don't get it right, you get vapor condensing in the structure and causing damage. So it's not there on a whim. These elements, air tightness, thermal bridging, high levels of insulation, and proper ventilation, they're all there. It's not arbitrary. They're there for very deliberate reasons, because people who've studied the evidence understand what works and what will make a building fail. That's great. I think there were a couple of other questions. One around preference to underfloor heating or radiators. I don't know if anyone wants to field that, but is there a preference for underfloor heating or radiators?
It's not really. Underfloor is terrific if you have the budget to do a whole house in it, and the costs have come down tremendously over the last couple of years. It's you've got a steady temperature there, 35 degree, let's say. If it's a highly insulated house, good slab in it, you could run that at lower temperatures, maybe 32. The big thing about it, and it's comfort, it's a great comfort, it's an even comfort throughout the whole house, but it really comes down to budget. If I was building a brand new house tomorrow myself, I would underfloor upstairs and downstairs for it. I think it takes up aesthetically, there's nothing on the walls, you can move your furniture around, everything. So, but it comes down to costs really in the end. But if you've good radiator systems, that's why there should be always a heat room calculation, done room by room calculation, so that you make sure that you have proper output for heating each particular room. But underfloor is fantastic, but let's face it, for retrofit, it's very expensive and it's impossible to do in a lot of projects.
Then there's a final question. Thank you, Ian. There's one final question, and we'll conclude on this one. Finally, guys, thank you, everyone. I've heard issues surrounding exhaust air heat pumps. Are they due to operation or design of the heat pump?
I can't really comment on those because we don't manufacture an exhaust air heat pump. We've always stuck with what we know. Sometimes I wonder, you're designing this fabulous building and making it completely airtight and then coring 2 big 6-inch holes in the wall. So I ask about that, but they seem to be very efficient, and especially in smaller apartments, and that feedback is good on them. But air to water, air to air, ground source, that's our main hallmark.
I think with all I'd add is a comment on exhaust air. There's a couple of things. One is that we published a case study, a news story rather, on a house in Niels Johansson from formerly the Swedish Trade Center, who put in exhaust air heat pumps, 2 of them, in quite a large, what was then avant-garde low energy building 21 years ago. And we spoke to him very recently for a news story in the mag. And he was very, very happy with them. So they have a longer history of use in this country than people may think. There can be an issue, though, I accept, where depending on the design of the exhaust air heat pump, if you are increasing the ventilation rate in order to generate hot water, for instance, I think that can be problematic, and that needs to be. You'll find exhaust air heat pump companies who have good answers to that, I'm sure, but it's a consideration. Okay, great. Well, look, I'll thank you for being so patient. Sorry for running over. I have a tendency to over elaborate myself, as there's a bit of a in-joke in the industry, so at my expense. But look, I'd just like to thank everybody so much for attending today. and to all the partner companies for being involved in this event. It's I've certainly learned a lot, and I think the whole industry has so much to do now to ensure that we don't just tick boxes and that we actually produce successful buildings. The knowledge is out there, the solutions are out there, and if we sit up and pay proper attention, we won't, we don't have to make mistakes. We don't have to end up coming back in a few years' time wondering what we need to do better. The solutions are out there now. All of these CPD seminars that have been hosted over the last few weeks, including this final plenary, are being recorded and made available online on the Partel and Core YouTube channels. So just at that, just like to thank everyone. Thanks for the opportunity to be involved, and get out there and design and build the best low energy buildings possible.
Before you go, Jeff, I'd just like to take a second to thank you very much for your generous time, information, and the same to all of the attendees and the speakers. And probably those that we don't see did much more work than all of us. So huge thank you to Ulia, to Brian and Lisa. I have an idea of how much work goes into presenting this, but not in a full appreciation. So yeah, it's
absolutely. I'm a terrible man for neglecting to attend to these kinds of things. But certainly, I've been very impressed with the diligence that they showed in that. So look, thanks so much to everyone. Thanks to all the partner companies, look forward to seeing the resultant buildings for consideration for publication in future issues of Passive House Plus. Thank you.
Cheers.
Thanks, Jeff. Thanks, everybody.
Take care.
Cheers.
Thanks.
Thanks all.
Bye-bye.
Cheers.